inventors that are here to hear the presentation. Thank you guys for coming.
Hello, I'm Kate. This is Chuck, Tommy, Jacob, and Tom. And this summer, we were tasked with finding the commercialability of a heat exchanger. And with that, I will let Jacob explain what a heat exchanger is.
Okay, so for those of you who don't understand what a heat exchanger is, it's a way of recovering energy from exhaust fumes. So in a normal residential home, you have air that you have to vent out, and you have to pull air in. So a very simple example of this is if you were to pull air in through the blue channel while exhausting air out through the red, you have basically a tube within a tube. And so you have hot air on the outside and cold air on the inside. And by running that over a given length, you end up with some energy transfer to the incoming air. So you're basically preheating the air on the way in. The difference with the patented technology that we have is a few things. First, the inner tube is made of a permeable membrane, like Tyvek, which allows moisture vapor to transfer through. This is very important because with water vapor comes a lot of thermal capacity, so a lot of heat goes along with that moisture. And then the other piece that's very interesting about our technology is the outer tube is actually made of a series of inflatable tubes. This provides a couple of advantages. One is it's very easy to install because you can just roll it out in a sheet. And then on top of that, it actually, because there's a channel of air between the inside and the outside, it actually provides a lot of thermal insulation. So you're not losing heat to the outside of the pipe, more of the heat is being transferred to the inner pipe where you're actually pulling your air in. So that being said, being made of plastic material, it'd be very cheap in comparison to a lot of conventional heat exchangers. And however, it's not quite as efficient because a lot of heat exchangers on the market today are in the 90 to 95% range or even higher, but they use a lot of precious metals, which are very expensive. We weren't briefed on the
So we explored several different markets. The inventor identified a couple of residential use and potentially lumber companies in the Kilman Island lumber. We broke down the residential into several different areas. There's a retrofitting for older houses. Older houses tend to, after our research, we found older houses tend to have fresh air intakes from inside the house, which sort of negates some of the benefit, as well as it can come into installation problems with long runs and turns, and you end up with ducting in one area, for instance, the crawl space, and the individual area place. Our product would be in the attic, and so you have to have some sort of connection through the floors, which is also a problem in newer homes. Newer homes are going towards more of a sealed air system, so they do have the fresh air intake from outside the house, and that was what we looked at as being a potential good place to go. However, the industry has already begun to place the more expensive heat exchangers within their essential units. So the industry itself has already decided to go in a different direction. We didn't think the adaptability would be very great in that area. We looked at greenhouses and commercial cold storage as well, just thinking in terms of any kind of industry that uses that has to manipulate the atmosphere in any way. With greenhouses, unfortunately, if it's too hot, they just open everything up. If it gets too cold, they just don't do anything. That was basically pretty open and shut on that one. Commercial cold storage, we figured the high energy usage of the particular coolers and refrigerants. Unfortunately, they use a closed loop system. They don't have no fresh air intake at all. We came up with manufactured homes, however, and that is a totally different story.
So the great thing about manufactured homes is, as you can tell, that the revenue growth has actually been 3.2% since the economic downturn. Another great benefit is going through the HUD numbers. There's actually been a 3.6% growth rate yearly in the new home placements in the market. So that's a really great indicator that this industry is going to keep on growing. major players in this industry are Clayton Homes. Clayton Homes is a Berkshire Hathaway company, and they currently produce 45% of the manufactured homes sold in the marketplace. And they're the only manufacturer that actually ships internationally, with a whole lot of their products actually going to Canada as well. Champion Enterprises is about a 2% market share of the industry base, and they actually bought out Fleetwood Homes, who was the market leader before 2009, when the manufactured home industry crashed horribly bad. And Cavco, it was the second largest company in 2009, and they just emerged out of bankruptcy, and they're growing quite strongly. Clayton Homes last year manufactured over 40,000 homes, and they've actually shown great interest in our product.
Great.
So some of the pros for the manufactured home market is that it's a highly adaptable market in that because they're building it on the floor, on the factory floor, they're able to adjust and build around the heat exchanger that we have. In addition, because we know their specific design needs, because they're making so many of them, and because they make sort of only a handful of models, further research into our product would be it would be easy to direct in a very specific way. In addition, manufactured homes have a lot of space in attics that we can use for this particular product, and manufactured home makers are a very price-driven market. They're very much into the cheapest product, which ours would be if it was manufactured. Some cons or concerns. First, it has to meet the HUD 3280 code, which basically just is saying that there are certain requirements that any sort of ventilation system must have. Second, it has to be able to do a 180-degree turn in the attic. Because of the length of our product, it has to be able to make that turn. Otherwise, it won't be the length won't be long enough for it to be efficient enough for them. The market size is relatively small because it is only manufactured homes, and it's only one piece of an HVAC system within that. Further, the patent 10 years ago was patented, and so we only have an additional 10 years to work on getting this out into the market before it's no longer protected. And finally, it's an unproven concept. There is some research done already by the architects who are in this room, which is good. More research is necessary before we can go forward, before Clayton Homes or anybody. They expressed interest, but in order for them to be able to buy it, they need more research to be done.
So next is the business model that we've identified. And because Clayton Homes has showed such interest in our product, if we can prove it, we believe that forming a strategic partnership with them is kind of the best route to get into the market. A strategic partnership is different than a legal partnership in that we both would maintain our autonomy, and it would give us the ability to grow and move and adapt to what they needed, as well as partner with them, or as well as seek out new markets and look and see where the adaptability can also change. There's two funding opportunities within this, and we've identified both Oregon Best and SBIR. Oregon Best is a great opportunity because it's local. Clayton Homes is located in Albany, we're here, and this would be a great funding opportunity to do further research to develop our product and make sure that it is a proven concept. Because our patent belongs to the University of Oregon, and with our research done, we believe that starting a small company could also help gain an SBIR grant to further develop research also and move forward within this market.
Takeaways, in summary, we identified some weaknesses to the concept. There's some issues with mold potential depending on ambient humidity for the specific geographic region that it might be placed in. There's the unknown lifespan of the actual product itself depending on the materials that are used, unknown manufacturing costs. There's threats, there's the path of patent lifespans that are gone, there's the HUD standards which may or may not change. Assumably if they change in that direction, it's bad for us. And there's also potential tax incentives for other products that might be competing. However, for our strengths and opportunities, obviously it's a platform technology, it's a low-cost alternative, be easy to install. opportunities, it's highly adaptable, funding opportunities for the market potential. We've been a partner, we've identified the market, the industry itself is extremely interested in the technologies. And question?
I'm not sure if I missed this, but what was the genesis of the convention? Why was it originally created, and what problem was the inventor trying to go after?
So the main problem is that most heat exchangers are built into units. So if you have an existing system, you cannot add on the exchanger after the fact that you've already manufactured it. And heat exchangers in general are extremely expensive. So they wanted to create a low-cost alternative. And so that's the genesis of it.
Present heat exchangers use the power for radiator form of energy transfer between $2,000 and $4,000 per unit. And we're hopefully our best guess on manufacturing market is more like $50 than
Jacob, thanks for explaining to me what heat exchanger was. What is the further research that needs to be done on it, I guess?
So right now, so far, the patent they've worked with, they made it out of foam board, so they actually haven't made the product out of plastic yet. And so we need to make sure that it actually works and that we do get the expected heat transfer to meet certain energy efficiency standards. We need to get a certain thermal transfer point, that being below about 80%, which is what our product was running. We also need to look at what overall efficiency it's going to run with specific heat, air conditioning units, because there's also potential for a lot of drag inside. So if you have a tube and it has a whole bunch of other tubes in it, it's much more susceptible to air drag when you're trying to push air through the system. We also need to look at mold issues. So because Tyvek is permeable and water vapor goes between it, there has been some cases where Tyvek has grown mold, and that's a serious concern if you're talking about living space. So we need to either solve that with pre-filtering the air on the way in, but it's just things like that that need to be addressed. And again, we need to meet the 3280 HUD standard, which is the standard for manufactured homes and things like that. So a lot of it's testing and things like that.
I mean, one of the, have we considered working with the chemistry department on essentially nanoparticle coatings for the Tyvek to address the mold problem?
I had not thought of that, but I have talked with the chemistry department on other projects, and I do know that they're working with silver nanoparticles to get rid of mold issues, specifically with dry fit shirts from Nike, things like that. So that is definitely a potential opportunity there.
So, did you say it was patented for about 10 years now? So, if it's been patented for 10 years, what is the biggest roadblock from actually making a working sample as you would, market it?
I think the biggest roadblock at this point is just getting the money to do further research. They've done kind of a proof of concept and it looks promising, but getting the further money to develop something that's only 80% efficient is not something that a lot of people are jumping towards because it's going to be such a low cost alternative.
Yes, excuse me. I'm still a bit confused because I don't understand the problem that needs to be addressed by this retrofitting heat exchanger. And when I saw the potential applications, they seem to be more directed towards where can we place the heat exchanger versus where are situations that have a problem that this heat exchanger can address.
I think,
anything, any industry or application where you're dealing with manipulating the atmosphere, that's what we're dealing with. So the heat exchanger is lowering the costs of doing that manipulation, whether it's heating it up or cooling it down. It works in both directions. And so any place where you're actually having to deal with that is a potential place for this technology to be utilized.
but I
So
think
can you name a few customers then? Would a manufacturing plant have this problem? Would a
Yeah.
gym or a fitness club have this problem.
Absolutely. Anywhere that has an air conditioner, anywhere that has a heater. So yeah, from homeowners to industries with warehouses to greenhouses to lumber kilns, it's pretty wide, just again, based on getting that air with
With that being said, one of the things we looked at was new residential homes, and a lot of HVAC systems that are being installed now have built-in heat exchangers, and they're in the cost, so that's one of the reasons that, a new HVAC system costs so much, is because you have this, $1,500 to $2,000 heat exchanger that's built into it. And so the difference is that ours is much cheaper, but it's not quite as efficient. And so, again, it takes more design work, so you need to have this venting space. A lot of times you need a longer run, and it is a little bit bigger than a conventional. It's about a 12-inch diameter at minimum, and of course, the bigger you get different thermal properties from that.
With global warming, we're feeling it this summer. Is this a good DIY project for people that don't have air conditioning? Put it in their attic and solve the problem?
Well, so if you don't have air conditioning, you still need to have forced air. You still need to have air moving through your system. We started to look into some of the emerging market kind of applications, but it's very difficult because they don't have fans and things like that that are trying to push the air through. So it's a little bit difficult there, but it's
Theoretically, what it's supposed to be doing is keeping the temperature at a constant, so it's pushing air in that should be, that's colder and making it, so that it's always staying at a constant temperature as it comes into the system. So theoretically, it's supposed to help you be more green.
We also did look into retrofitting, older homes, and that is a potential for do-it-yourself. We looked into Lowe's and Home Depot as an opportunity. That might be something a little bit further. The problem is that the market is so fragmented. A lot of people aren't willing to crawl up in their attic and redo their ducting. It might be something that they get a handyman to do. So we also looked into the potential for getting a certification to help you with some of the stuff, or how much it would really lower your heating and cooling bill. But it might take some larger retrofits in certain areas. For example, a lot of older homes, instead of pulling air in from the outside of the house, they actually pull air in from a different part of the house. So it's the same temperature that a heat exchanger wouldn't do you good, because the air that's coming in is the same temperature as the air that's going out.
So you said that high efficiency furnaces, for example, are much more efficient than your product at doing the heat exchange, and that's why that's not really a viable avenue for you to go down. But in the manufactured home application, where you found that it may prove fruitful for you to continue on that path, I assume that you said somewhere in the 80% range, that's less efficient than a high efficiency heat exchange, which costs more money up front. I assume that it's going to cost, their power bill will be more expensive, but then you just mentioned that there's some savings on your power. So, first of all, are there real savings on your power bill? And second, how long does it take? Because you have a less of an upfront cost. So, how long does it take to, if you are spending more on power, how long does it take to catch up to that initial expense of the more efficient heat exchanger?
So, you want to talk about calculations?
Yeah, I've done some calculations. For heating degree day, and you determine that upon the area. And the more efficient your furnace is, the less energy you're expending to begin with. But what we calculate is what the 80% efficiency will actually save you in power bills over time. So you just multiply that by the amount of energy you would save per year, which is what you would get by using the heating degree days in this long, complicated equation, which if we had this slide, I forgot to put it on the slide. But we calculated for Eugene at a 6.7 cent kilowatt hour savings with a heat exchanger with a furnace that was about 85% efficient. You'd be saving at least $15 per year by running our heat exchanger in your home. And the problem is that with manufactured homes, they always run the most cheapest stuff possible because price is of the ultimate concern for all manufactured homeowners. So having some sort of energy saving device, especially in areas like Texas, Florida, and Georgia, where manufactured homes are mainly built and placed, where the energy is actually double of what we pay here, is actually a quicker payback than what we experience here in the Northwest, especially.
Yeah, see, that's one of the problems with that, is that it's very dependent on place, right? Because you don't have nearly as much heating and cooling requirements here as you do in Phoenix. And then the end cost of energy, right? Because we have so much hydropower here, it's not as expensive as some other places. So it's kind of variable. We calculated for about $15 in Eugene, but we think it's going to be closer to over 100.
Well, in Fargo, North Dakota, you'd be saving $50 a year with this exchanger versus in Eugene where you're saving $15, right? So you could get a 3-year payback in North Dakota, but a 10-year payback in Eugene.
Other questions? Last one? All right, thank you guys. Thank you to all the teams. This is the end of a lot of work. Don't forget to send me your final reports by Friday. I can't grade them because it's not a graded effort opportunity, but I know that these guys have put a lot of work into their projects over the summer. Many hours, many phone calls, many dead ends of ideas. Fish in the desert Southwest. I think this heat exchanger team thought it might be useful for lumber drying kilns. Apparently those are way too hot and way too steamy for this application. So what's the other good ones? Yeah, the veterinary market. Just trying to think of the other sort of high-profile dead ends we had here. You guys had
Nail glue?
nail glue. Yes, yes. We're gonna have
Fast, but yes.
yes. Nail salon glue. That was one of your first ideas. Interesting. You never know what's going to come up in this this situation. So I want to say thank you to all of you who have come from near and far to be here and listen to this. Hopefully you took away something useful, some negative an idea to our, I guess I'll call them our customers, folks from Oregon Health Sciences University, PNNL, and Nettle, and U of O. Hopefully gain some insight into the opportunities for your inventions, the markets that were potentially applicable, and I welcome your feedback to me about the process. We do have an open to everyone reception that should begin. We should have catering ready in about 10 minutes in room 440, which is on the 4th floor of the Lilith complex. If you go out the door to your right, top of the stairs, top of the round stairs, you'll see a room with some snacks, some drinks. That's open to you all. I'm happy to have you stick around and network. With that, I just want to say thank you to my co-conspirator in this project, Al Cochran. He and I spent a lot of time figuring out how to make this program work every year. We go back to our technology providers every year and say, hey, do you have anything new and exciting you'd like us to check out? Sometimes it's something old and exciting. In the case of the heat exchanger, that was a patent filed like 10 years ago. But I think we did some good work figuring out where that would have an opportunity. And we put this thing together. We're looking to expand it and do more with it. And hopefully you'll see these students out doing something exciting, either when they finish law school in 1 or 2 years, or the MBAs who will finish after another year. Some of them might start companies. Some of them might just be good, hard-working attorneys billing 70 hours a week. But all of them are going to walk away from this experience with skills to analyze opportunities and understand how to build an early stage business. And that's what we're here for. So thank you again to everybody for being here. Appreciate your time and attention. And Foods 4th floor, room 440, you're welcome to join us. Yeah, always talk about what they Good question, I'm listening.
Yes. I'm glad to learn about this. I just saw it on Facebook yesterday, so it's like I'm gonna go.
Okay, cool.
I'd like to get on some type of list if you have one.
Okay.
Key things are happening or something.
Yeah, I will. Nice. Where are you coming from?
And so now I'm interested in studying the psychology of entrepreneurship, like why let's get into it and how that affects
Oh my God. You're already in furlough.
Yeah, there's no reason for me not. Well, yeah, they show up too. But like, it makes it sound like it's a really easy thing. It's like they're ready for some reason. It's not like taking 16 credits and have to pay 3,000. That's a different question. That way, like, not using everything on more credits. So, yeah, that's sort of the plan. Yeah, maybe I'll put it together. That's good. Yeah, because we have that. Started to be they just came from they're trying to
Have you seen
We might have only got maybe 10. That would be
well, you must have been so he just wanted to change the amount of
saturation point is the hard thing. Reasonable size, the reasonable size is dropping.
so it costs all this.
Yeah, we are.
I'm gonna give this.
He'll make it better.
I don't know, not yet.
Well, if you see
Right now, last time I talked to him,
We visited, right?
hey dude, what's the first name? Dave. Yeah. So are you a billionaire now?
Yeah, yes.
Are you
Very godly.
Are you still involved? I got the honor.
All right, nice, thank you for coming out. Yeah. See you, sir. How's the rest of the
So, I do your deployment on
Yeah. So, well, that's right.
Yeah, so,
then you're out of school.
Yeah.
Good. And I'm glad you stayed.
Yeah.
At Oregon State, we need smart young guys.
Did you get my slides?
Yes.
Good. I like it. Yeah. And the other thing, I was actually thinking about it, starting to think more about pictures.
Well, I'm over there tomorrow, so.
Well, because I think you guys are more like craft, there's a spring winter that we're going to do is just play. That could be more. But they just gotta be. And then of course, spring winter, playing come to Oakshire, celebrate the big games. But the sun is really turns.
Yeah, we did have more to turn.
Yeah. But I've been kind of betting.
Let me give you some feedback. I'll float it tomorrow.
Okay.
All right. I was on Dan. That's what he wanted to tell us what he would like to do.
Yeah.
I'll see you guys. Good seeing you. Good luck to you.
Well,
I'm gonna go down to I'll see you later.